Okay, so we're doing 2.3 velocity, acceleration, and second derivative. Okay, so now what is the displacement? Displacement is the vector, the initial position to the final position. The distance that the object is moved, it has direction and it has magnitude. Velocity, it is vector as well. So it has a magnitude and it has a direction. Velocity is the change in position over change in displacement over time. Basically, displacement over time is say velocity, changing in displacement over time, period of the time. This is the slope of displacement time graph. Basically, if you have a dx, say is equal to x power 2 plus 5x, the slope of this will be your velocity or the derivative of displacement graph. Actually, it should be as a function of time. That's fine. Just make sure it's clear. If you have displacement as a function of time, you take a derivative of that respect to the time, changing displacement over changing time means the derivative of that. It will give you the velocity. So the velocity is power, derivative of the power t is power in front, power minus 1 is 2t. Here's a line, the derivative of that is 5. This is your velocity function. Now acceleration. Acceleration is the rate of change of velocity with respect to the time. Basically, derivative of the velocity will give you acceleration. Let's just do a question. Determine the second derivative at point 2 for a function f of x is given to you. So the first derivative, power in front, power minus 1. 3 multiplied by 1 over 3 is 1. Power minus 1 becomes x power 2. Power in front, 2 and power minus 1, so the power of x is 1. Negative 3x is a line, so just derivative of that is negative 3. Derivative of constant is 0, so it doesn't have here. Second derivative means you take a derivative of the first derivative. X power 2, power in front is 2, and power minus 1, power of 2 becomes 1. Negative 2x, the derivative of negative 2. Now, when I find the second derivative at point 2 means instead of the x, you just simply put 2 everywhere. Instead of x here, you put 2 and you evaluate it. The second derivative represents acceleration. The first derivative represents velocity. Okay, see, and let's say if we have f of x, I want to see how can I graph f prime and f double prime. I'm going to explain that here. So here. So first I'm gonna draw what I have here for f of x. This is let's say this is my f of x. I want to draw f prime, so I just do the same thing here. F prime x is the slope, right? So slope here, the tangent line here is horizontal, so the slope here is going to be 0. First, I'm gonna find a 0. Thereby f prime is 0. Of course, at maximum and minimum, this tangent line is horizontal, the slope is 0. My first derivative here is going to be 0. Same thing, tangent line is horizontal, the slope is 0. So first thing I do, I put zeros of my f prime. Then I'm gonna say, what is the slope from here to here is positive, right? Therefore, I need to come from this side. I cannot do like this, because if I do that, the slope gonna be the f prime is negative. But I know slope is positive, so I should make sure my f prime is positive. Okay. Here, the concavity gonna change, the concave down and then up. True. And the concavity is changing, means you have maximum or minimum. Of course, I have here the slope is negative. The slope negative means I have to really be here, and it's become, I need to go to 0 as well. See, but how do I know where do I put my minimums? You put your minimums at the place where your concavity is changing. Your minimum. Again, here concavity is changing approximately here. So at this point, you need to have maximum or minimum. Again, the slope is positive and go to 0, right? So make sure this is positive and go to 0. And as you see, this concavity is changing there. I have maximum. And after that, the slope is negative, right? So I have to simply go there. This is the approximate draw. Now I'm gonna graph second derivative. So second derivative f double prime x. Again, I need to find the zeros of my function. Here I have maximum and minimum. The slope is the horizontal line. This is going to be zeros of my f double prime. Here and here, right? The slope here is negative from here to here. I have to go from negative to this point. The concavity, it seems that the concavity is changing there. You have a maximum minimum there. Also, the slope is positive, so it means you have to really be above that. So the concavity here is changing, so it's a maximum. Here the slope is negative, so let's go down. So the first derivative is velocity, and the second derivative is acceleration. Here is saying that if you have t as a displacement, the velocity is the first derivative and acceleration is second derivative. The unit for this velocity is meter per second. For acceleration is meter second square. Speed versus velocity. So speed is a scalar. It just has a magnitude, it doesn't have a direction. But velocity has a magnitude and direction is a vector. So here, this is displacement time graph, right? As you see the slope, you have some slope, and slope becomes sharper and sharper, right? That's why you're speeding up. And here is the slope is getting smaller and smaller, like this tip. It's gonna be a lower and lower slope, and here is slope approximately 0. This is slowing down. So it's concave up means acceleration. Concavity, okay, concavity represents acceleration. Acceleration here is positive, but concavity is concave up. Happy face. Sad face, concave down means acceleration here is negative, or second derivative going to be negative. Here slope is positive, so velocity is positive. Here velocity is positive as well. So you can make a conclusion that when the acceleration and velocity have the same sign, is a speeding up. But if they have a different sign, one negative, one positive, it is slowing down. This is if the velocity acceleration is both positive or both negative, it's going to be speed up, and if both negative, one negative, one positive, slowing down. So concavity, as to say, concave up means concavity up means your acceleration is positive. Concave down is acceleration negative. So here from D to A. So from D to A, what is happening? This slope getting sharper and sharper, and it's positive. So you speed up. From A to B is a speed down, right? The slope become, you have high slope here and becomes 0, right? So it's slowed down and stop here. From B to C is a speed up, but a speed in negative direction, see? Become very negative slope. From C to D, assume that this is the curve and the slope getting smaller and smaller. From D to E, the slope is 0, right? The velocity is 0. E to F, again, it becomes very sharp negative. So it's speeding up, but in negative direction. So that is question 1, 2, and 3. You try it as homework for this worksheet.